All right, you guys, so we have this inscribed rectangle, which means all of the corners of this rectangle hit the triangle. And we know that it has a diameter of 10. So if I make a middle point here, this is going to be 10. I have a right triangle. I can now use, to find the other side of this rectangle, I can now use Pythagorean theorem. So I know that 2x squared plus some value, let's just call it the other side, or like we can even just call it question mark. I don't want to call it x because I'm already working with x. I could just call it b, but we know that whatever it is needs to stand for the other side of that triangle right there, which is also the other side of the rectangle, equals, and then 10 squared is 100. So look at what I'm doing here. It wants us to express at the end, what I'm trying to get is it wants us to express each of the following, I don't know why I can't do a straight line there, quantities in terms of x. So I'm going to solve this and have only x on the other side. So 2x squared times 2x squared is going to be 4x to the fourth. So if I subtract 4x to the fourth, oops, nope, that's not what I meant to do. Up here, this should be 2x squared. I'm sorry, if I was a better teacher, I'd go back and redo this so you didn't get this far and have to erase, but I don't want to. So 2x squared is really 4x squared. So I want to subtract 4x squared from both sides. Cool. And then I have now b squared is equal to 100 minus 4x squared. Okay. And I need to take the square root of that to get b by itself, to figure out the side length over there. Okay. So b is equal to, and I want to say I can take a 4 out. I'm going to factor a 4 out, and I'll show you why. Is equal to the square root of, and then I'm going to factor a 4 out. So it's really 4 times 25 minus x squared. Okay. And that's the difference of squares. You can't really take the square root of the difference of squares because you end up with a negative under there. But what I can do right now, you're not going to have anything squared, but what I do have is I'm multiplying by this 4, which I can take out. The square root of 4 is 2. And the reason why I'm doing that is because that gives me a little bit more of an idea of what this looks like. Times 25 minus x squared. So this is really the side of the triangle that I don't have. Then, in order to find the perimeter, I have to add all of those sides up. So I have 2x plus 2x plus 2 root 25 minus x squared plus 2 times root 25 minus x squared. So my perimeter is 4x plus 4 square root 25 minus x squared. Okay, and I'm just going to leave it like that. I guess you could factor out a 4 there. You don't need to. But this is really the perimeter. Not pretty, but that's the perimeter. And then my area would just be 2x times 2 times 25 minus x squared, which is just 4x root 25 minus x squared. All right, what's up next? What's up next? Solve for x and y. This is a system of equations, but I'm not going to get a number answer because I have 4 variables and only 2 equations. So what I'm going to have to do is solve for x and y in terms of a and b, which is okay. So let's just do it like a normal one. I'm going to multiply the bottom fraction by 2 so that I can get opposite. So I have 3x, I am not changing the top equation, 3x minus 2y equals a. And then my bottom equation now becomes 2x plus 2y equals 2b. Now the reason I did that was exactly what happened here. I now have a negative 2y and a positive 2y, so that when I combine these two equations, those are going to be eliminated, or they're going to eliminate each other, however you want to do. So let's combine these. So 3x plus 2x is 5x. My y's went away. So 5x's is equal to a plus 2b, which means x is just equal to a plus 2b divided by 5. So that's one of our answers it wanted. This time, so let's just leave that there. This time let's go back and I'm going to eliminate the x. So instead of multiplying that bottom equation by 2, I'm going to multiply it by negative 3. So now my top equation is still 3x minus 2y equals a, but my bottom equation is negative 3x's. See, now I'll eliminate those. Minus 3y is equal to b. Oh, minus 3b. Minus 3b. That's an easy mistake. You guys have to put that 3. Geez, disseminate that 3 throughout the whole equation. Okay, now my x's cancel. Now I have negative 5y equals a minus 3b. And y is just equal to a minus 3b divided by negative 5. Okay? All right. Where do the graphs of x squared minus y equals 4 and y equals 2x minus 1 intersect? So let's just do this. There's no reason we need to put ourselves. We can just put this into the calculator. So we go to our y equals. Let's clear out everything you have in there. And, oh, we do need to solve this first one for y, though. So y equals 2x minus 1, that we can just put in already, right? But x squared minus y equals 4 is not ready yet. We're going to, let's do this. Let's add y to both sides, right? If I add y to both sides, I get 4 plus y is equal to x squared. Now all I have to do is subtract 4 from both sides. And y is equal to x squared minus 4. Now I can put both of those in. So x squared minus 4, and then 2x minus 1. And I'm just going to do zoom 6, see what that gives me. That's our standard negative 10 to positive 10, negative 10 to positive 10. Cool, so I'm going to have 2 answers here because that first one, obviously x squared is a parabola. Second one's a linear relationship, so as you can see that they intersect twice. So if we go second calc, we want to find the intersection. Whoops. Cool. So it's going to find, first of all, it's going to find this one over here because that's where I'm closest to. So I have to hit enter, 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 till it says intersection. So I get negative 1 and negative 3. So negative 1 and negative 3 is one of those intersections. Then what I'm going to do, you guys, is I'm going to trace closer to, where'd my guy go? I don't need to trace here. Where's my dude? Well, here, let's choose this. Second, calc, intersect. Here's what I wanted to show you guys. See my little spider dude? I need to get him closer to the other intersection point, or it's just going to find me the other one again. And then I need to hit enter, enter, enter. And this is 3 and 5. So those are the 2 points that they intersect at. Okay, 318 says, are the following expressions equivalent? Explain how you know using 2 different methods. So one of them is you could put those into the calculator. That's one method. Let's try that again. So we go back to our y equals, and we have the first equation is x squared and x plus 2 plus 3 times x plus 2 although I feel like actually this is probably the long way to do it. And then the other side is x squared plus 3 times x plus 2. Then let's just do a zoom 6 and see if it gives us the exact same line. Okay. Looks like the same line. I'm just going to double check because I don't have colors on this calculator, my table, and make sure that I have all at 6 and 6, 12 and 12. Yeah, so these are both the same. Okay, now let's do it a couple ways algebraically. So the first way is, check this out, you guys. If this is x plus 2 and this is x plus 2, right, I can factor that out. So if I factor out x plus 2, what's left over here is x squared, and what's left over here is plus 3. Okay, and now I have x plus 2 times x squared plus 3, which is x squared plus 3 times x plus 2. It doesn't matter because they're commutative, right? Multiplication is commutative. You could write it in any order. I guess a long way to go about it would have been to distribute and then multiply this side together also and see what it boiled down to. But I think that I chose the 2 easiest ways to do that. And do I have time? I don't. 319 is going to have to be a separate video.